to all of you. So we are starting today Moore machine and Mealy machine. So finite state finite machines with output. That is the topic we have today. Okay. So let me go for the presentation. So yesterday we have discussed about what is Moore machine, what is Mealy machine. So Moore machine, Mealy machine, we are considering output also. In the previous automata machines, we didn't consider about the output. We were worrying about only inputs, but here we are going for outputs also. We are considering. So let me present the just a minute. Yeah. Let me start the presentation. Yeah. Yeah. So this is what we started yesterday also. So far we have discussed about finite state machine without output, but now we are going for with output. So in this one we have Mealy machine and Moore machine. The Mealy machine output on transition we are considering, whereas in the Moore machine output on state we are considering. So Mealy machine if you take, so a Mealy machine is an finite state machine whose output depends on the present state as well as the present input. So we are considering the present input as well as the present state. And in Mealy machine, every transition for a particular input symbol has a fixed output. Means suppose if you are going for a state Q not equal to 0, you are moving to some other state, and Q not equal to 1, you are moving to some other state. But for both the things, we are taking one fixed output. That is what is meant. Sigma. What we have in DF and NFA, same thing for Q and sigma also. So sigma is finite set of symbols, which is called the input alphabet. Just a minute, someone is joining. Let me in there. Just a minute. So we are going for here. O is the finite set of symbols called the output alphabet. Yeah, because we are considering here output also, that's why we are going for output alphabets. Then delta is the transition function as same as NFA and DFA. Here delta is nothing but cross product of Q into sigma, which is going to map to Q. Okay. So then X is the output transition function where we will be having Q map into output function O. Map into output, some output. Q naught is the initial state from where any input is processed. So to understand this, we'll take one example here. Not this one, we'll take directly transition table because this you can easily understand. So here, if you see, we are having here present state, next state for Mealy machine. Here we are having state and output. A equal to 0. For Q naught, if you give 0, next state is Q3 and the output is 0. And Q1 is 0. For Q1, if you are giving 0, the next state is Q0 and the output is 1. For Q0, if you are giving 1, next state is Q1 and the output is 1. And for the Q1, if you are giving 1, the next state is Q3 and the output is 0. And for So let me take that ready this one. Just a minute, it is opening. Paintbrush. Yeah, someone is joining. Yeah. Yeah, let me move this side. Yeah. Yeah. This will go for today. Suppose if I'm going for a string, say 0, 0, just a minute, went up. Suppose if I'm going for 0, 1, 1. So here, so we are giving for initial state Q naught. This is our initial state. If we are giving 0, Q3 is the next state. Q3 is the next state. 0 is the input. And the output for this is 0. Output we are writing. So this is how we follow. For Q naught, you are giving 0. You are going to the state Q3. And for Q3, output is 0. Okay. From the transition table, we are going for it. Then 0 again. Input is 0 for Q3. Q3 0 is state Q1. State Q1. Q1 output is also 0. Then we are going for 1. Next state we have here is Q1 1. Q1 1 is Q3. Q3 we are getting output is 0 only. And I'm going for again next state with input 1. Next state we are getting Q3 1. Q3 1. Q3 1 is Q naught. So Q naught output is 1. So all these outputs we have to consider. So the outputs we have here is the output of this is we are going to have output here equal to 0. This one down one we have to consider 0, 0. Below the states what I have written that we have to consider. Equal 0, 1 is the output we have for the given input string. So like this we are going for finding the. So I think this. Yeah. So I hope now it is clear. Okay. Hope this is understood by all of you. Any doubt you can ask. See, same data output below the state. So because for a given input, what is the output string? For the given input string, what is the output string we are finding? That's why we are going for this. Okay. So this is what in Million Machine we go for finding the output. Is this clear, ma? Is this clear? Shall I go for the next? Guys, you have to answer me. Shall I go for the next, ma? Are you there? Are you there in the class? Okay. Then let us go for the next table. Next concept, Moore machine. In the Moore machine, what we have is it's also 6 tuples. where we have Q is the finite set of finite non-empty set of states. Sigma is set of input alphabets. Delta is set of output alphabets. Transition function is mapping of Q plus product of E into a state, and lambda is the output function mapping Q to delta. And see, there we are writing O, here we are writing delta. That's the only difference. There we are written X, here we are writing lambda. So Q naught is the initial state. Tuple is same, only this symbol, delta symbol and this lambda symbol, we are changing. Then coming to move transition table, this is our move transition table. Okay, so for this, how we are finding that, I give you. Oh, no, just a minute. How to see that now? Just a minute. Let me do this. Let me take the paintbrush here to explain one more thing. Let me. Oh, it is easily clearly visible. So just a minute. Let me go for view this one. Yeah. So now here. Yeah. Now we'll go for another string here. Let me take a string here. 1, 1, 0, 0, 1. Suppose I'm taking this string. So now here, what we do? Same procedure. So we start with the initial state. Initial state is our Q naught. For Q naught, we are giving input 1. What is the state? For the next state? For the next state for this? Guys, Q naught, if you give 1, what is the next state? See the transition table. Are you able to see the transition table? Transition table is visible to you. Yes, sir.
Yes,
okay. Q naught 1, what is the output? What is the next state? What is the next state? Next state is also Q1 only. The next state is Q1. So output here is 1. You see here, for a Q naught, if you are giving 1, you are going to next state Q1 and the output is 1. Then again we have to find out for Q1 1. Q1 1. Q1 1. Q3 is the next state. Output is 0. For Q3, again we have to go for 0. Q3 0 means we are getting Q3 0 means Q1, output is 1. Next state is Q1, output is 1. For Q1, again we give 0. Q1 0 is Q naught, output is 0. Q naught, output is 0. And for this, I am going for input as 1. And the output here I am having, what to say? Q naught 1. Q naught 1 is Q1. Q1 and the output is 1. So finally the output for this we are going to have here is output equal to, we have here 1, 0, 1, 0, 1. So this is how we are getting. From this transition table, we have to first start with the initial state. We have to give the input symbol where it is going, to which state it is going, that we are writing. Then we are writing the corresponding output for that. So in the Moore machine, so we have this one. Okay. So if you see here, we are writing the outputs, all the outputs finally we are writing. This is our output. This is our output. Okay. So this is how we are going for, say, Moore transition table. Is this clear, ma? Understood? Is this clear? Understood, all of you? Guys?
Yes, ma'am.
Okay. So let us go for next concept. So we increase this a little bit. Yeah. Let me go for converting from one machine to another machine. So we'll see Moore machine converted to milling machine. So what we do here is our input is Moore machine, output is milling machine. And what we do is here we take a blank milling machine transition table because we are converting it to milling machine. No, that's why we have to take a blank milling machine transition table. So I will take here a milling machine transition table. Let me take one example. For that, we'll go for it. Okay. So now what we have to do, whatever is there in the Moore machine, that we have to copy into milling machine transition table. Then we have to check for the present state and their corresponding output, and we have to go on writing. So this is what we are doing here. Let us see this example. So we are going for, say, a table. So here we are having our initial state and other states. Then we are going for 0 and next state will be having here. Just a minute. Yeah, forgot to use. Output this one. So here we are going for the next states. Yeah. So here this is next state total. This total is next state. So in that one we are going for, say, a equal to 0. What is the output? So a is equal to 1. What is the output? And this total is next state. Next state. And this is your present state. Present state. Okay, so here, suppose you are going for converting this, you have to first write all the everything as it is. A, B, C, D, everything you have to write as it is. Let me complete the table. Yeah. So we are going for a table here. So here now whatever is there in this one you have to copy. All the things what we have here from that machine you have to copy here. Now this is actually milling machine we are going for it. Now you have to copy A equal to 0, next state is D, A, C, B. And here we have B, E, C, A. So what we have done, whatever is there in the Moore machine, we have copied into milling machine. Now what we have to do, see here, take this A equal to 0, next state is D. Now we have to come to D. D here. What is the output here? 1. So this one we are writing here. This one we are writing here. Okay. Then we are having A is equal to 1. Next state is B. So B, for B, output is 0. So we are writing here output 0. Then here for B next state is A. A output is 1. Then D output is 1. C output is 0. C output is 0. B, for this B, what is the output? For the B also output is 0. For the A, what is the output? 1. So this is our, what is this? This is our milling machine. So we have converted Moore machine into milling machine like this. So initially we have copied this from the Moore machine only. This also we have copied from the Moore machine only. This also we have copied from the Moore machine only. Only thing what we have done is here, just a minute. Is this okay? Oh, okay. Now here, this is the present state. This is the next state. In the next state, we are going for A is equal to 0. All the states from the Muri machine copied, and all the states from A equal to 1 copied. Then what we have done for this D, what is the output? For the D, what is the output from Moore machine table? So here 1 is there. That one we are writing here. For B, what is the output? For B, output is 0. That's output we are writing here. Okay. And for C, sorry, for A, what is the output? 1. Okay. For D, what is the output? 1. For C, what is the output here? For C, what is the output? 0. So we are writing here 0. For C, output is 0. For B, output is 0. Like that, we are copying from the Moore machine only, but according to Mealy machine, we are doing it. So this is how we are converting Moore machine into Mealy machine. I hope this is clear to you. Is it clear, guys? Is it clear, ma? Yes, sir. Okay. So then we'll move on to the next one. That is, this is Moore to Mealy. Next we'll see about Mealy to Moore. Mealy to Moore machine. You can go through for few seconds or 1 minute. You can go through this once those who want. So reverse we are doing actually. The next one what we are doing, you just check it. We'll go for it. So next we'll go for. So this is what same thing we have here. Okay. So like this you have to copy and then you have to go for writing the states. This is what already we have done. And then we are coming to Mealy to Moore. So input is Mealy machine, output is Moore machine. So calculate the number of different outputs are available in the state table of the Moore machine. And if all are same, copy the state outputs. Otherwise, break them. So how we are doing it, you will understand with the example only. We'll go for for the example. With the example, you will understand easily. Yeah, this is sufficient. We'll go for a little bit. So now, so what we do here? See, if you see here, for D we are having here, for C, for D we are having here output 0. Okay. So A and D give only 1 and 0 output. If you see here, for A and D, D. Okay. So if you see here D and A is 1 only, D is 0 only. D is 0 only, A is 1 only. Like that we have to check now. Are you getting me? So how we are going to check? For D equal to 0 here, A equal to 1, C equal to 1, B is equal to 0. But B is equal to 1, D equal to 0. So here also D equal to 0, here also D equal to 0. So D is having output 0 only. Coming to B, it's not having same output. So coming to C, C is also not having same output. So A is equal to 1, A is equal to 1. So we are having for A and D same output. Now for B and C, we have to go for different outputs. For B and C, we have here different outputs. 0 and 1, 0, 1, like that we'll be having. So what we do is here, just a minute. So if you see here, for B and C, we have different outputs. So we divide B into B0 and B1. Because we have for B 0 and for B we have 1. So we divide, we call them as B0 and B1. And then for C also, we have two outputs, C equal to 0 and C equal to 1. So we call them as C0 and C1. So next, we'll go for C here. For the same, what we are doing, we are going for more here. Okay. You see here, we are having here for A, and D we are having same output. For A we are having 1, for D we are having 0. So this we have written. But for B and C we have different outputs. That's why we are going for B0 and B1. B0 means B with output 0, B with output 1, C with output 0, C with output 1. Like that we are writing. So and these states what we have there, same thing we are writing. So if you see the here, see here. So for B is equal to A1 is same, okay. But here you have B1. Output is B1. So next state we are calling it as B1. Okay. So let me explain this with the help of this. You will understand easily. The table. We have the table here. Present state. Yeah. Then we are going for next states will be having age equal to 0 and age equal to 1. Only one output we are writing. So only one output we are writing. So we are writing only one output. So we are going for here. Next statement, here we are going for age equal to 0, age equal to 1, and the output we are writing. So first copy the states as it is from. Okay. So mini machine A, B, C, and D. So I'm little bit giving more gap here for clear understanding. Okay. So now here, just a minute. Let me because this traffic tablet pen is not moving fast. Yeah. Just a minute. Yeah. Let me start this here. Yeah. So for A, next state is D. For this next state is A. See, here we have output 1. See, here we have output 1 because they are different. Here we are writing it as C1. Here we are writing it as C1. Next state. And B output here 0. So we are writing here the next state as B0. Okay. So we are going for, yeah, I forgot 1 minute. Just a minute. You have to write all B's at one place and all C's at one place. Just a minute. Yeah. How to go for here? Here we have to go for B0, B1. B0, B1 is not right. 2 we have here. What happened? Here we have B, B is here, B1, then C, C1, C0 and C1 we have to write actually. Forgot that step. Okay, for here. Now here we have to write here C0, go for the C0, C1. Number of states are increasing now here. We are splitting the indifferent output. Different output we are splitting them. That's why we have here more states. And this is our D. Okay. This is our D. So for A, next output we have here is from the transition table. Next output we have is B. So these are our next states. These are our next states. Next states. So outputs will let us write here first. States will write here. Let us write this as B1 because it is giving output B1. And for B0, next we are going for B0. Okay. So B0 and C0. So B0 and B1, C0 and C1. So D will write first because D we know it. B0 and this is our A1. Okay. So the output for this A we have is 1. A equal to 1 and we have D equal to A equal to 1 and D equal to 0. So here 1.
Ma'am, we are unable to watch the graphical tab screen, ma'am.
Screen this paint one, this paintbrush.
Ma'am.
Okay.
Yeah, ma'am.
Yeah, paintbrush, let me increase the size. Yeah, I'll do the next yesterday's method. Just a minute. I'll take that side like yesterday. Just a minute. This one I have to move. Just a minute. This. Yeah. Now is it okay, ma? Are you able to see? Are you able to see now? Torna, are you able to see now?
Yes, ma'am.
I can see.
Want a little bit this, yeah, more only. This. Yeah. So what we are doing here, this D equal to, for A, you see here. See here, D equal to 0 we have here, D equal to 0 we have here. Here also D equal to 0. So that we are writing here. So here we are writing for A equal to, for A, if you see here, we have for A 1, here also 1, here also 1. So we are writing that here 1. Here we are writing 1 and here we are writing 0. Just a minute. Here for D equal to 0, both the places. Okay. Now we are going for B0 and B1. B0, B1, C0, C1. See, they are different. So the outputs for them we have different. So for B0 what we have, for B1 what we have, that we have to write. Okay. So for B0, you see here B0 and B1. B0 if you see here A, D. We are going for same AD only we are writing. We are writing same AD only for B0 and B1. Next states. For C also we are writing C and C only. You see here, we are writing both same only. Okay. But based on the output we are writing it. Okay. So the next state for this B0. Now B0 we have tried the next state. For B0 next state we have is here A and D. Okay. So we are writing here A and D. Here we are writing A. Next state is D. Okay. So, but here if you see here, A and D is there. Okay. Because there is no change. Okay. So B0 means what is the output? We have B0, we are going for B0 and B1 now. B0 means output 0. And B1 means output 1. Based on that, we are writing here 0. See here. Based on that, we are writing here 0. I'm not writing anything else. I'm just explaining the concepts. Okay. So now here also we are writing A and D. But as it is B1, here we are writing output as 1. Now for C, we have here C and C only. Okay. So what we do here, this we got as C1 because output is 1, and this we got as C0. So C1 and C0 we write here. So we write here C1, C0 for the both the places. C1, C0 the both the places. C0 means output is 0. C1 means output is 1. So this is how we are converting. This is little bit per se different than more to milli. But here we are going for, see here, milli to more is little bit different. So first of all, we have to check, do we have the same output for the states? D equal to 0 here, here also D equal to 0. That's why we are first going for D equal to 0. And then here A is equal to 1, here also A equal to 1. So we are writing 1. And the states what we have, we are writing D. One state is D, the other state is B. B but output is 1. So we are writing here B1. So we are writing here, based on that we are writing. Now here how we are writing B0 and B1. So we are writing A and D. For B0, A and D. Same thing, AD, AD we are writing. This is B0. B0 means output 0. So we are writing here output 0. Here B1, 1 means output 1. So we are writing here output 1. And for this C0, whether it is C1 or C0, the output is 0. Because it is C0. C with output 0. C with output 1. So C1, C0, same thing we copied, but we are writing it as 1. So this is how we are converting our machine. Okay. So is this clear now to all of you? Is this clear? Converting milli to Moore machine. This is converting milli to Moore machine. This is converting milli to Moore machine. So based on this we have converted. Based on this we have converted. So same state we have to consider, same output we have to consider. With different output we are dividing the state into two parts. Output 0, output 1. If you have three outputs, B0, B1, B2, like that we can write it. So based on the output what we are having, if they are different. Here we have B is equal to 0, but here we have B is equal to 1. That's why there are two outputs. Like that we are taking it. Okay? Fine. Is this clear? Is this clear, ma?
Yes, ma'am.
If not clear, tomorrow also you can ask me doubts. Okay? Don't worry. So go through this once. I'll send this PPT to you people. Go through once. If you have any doubts, again you can ask me. I'll explain you again. No problem. Okay? Once or twice till your doubt is clear, I'm ready to explain. Okay? This one. As time is up, shall we close? So we are closing here. Let me close this. Close this. Stop this presentation.